Hello everyone, now we are going to solve the questions based on the partial balancing. First we need to read the question. In the question it is given that in case of partial balancing of the single cylinder reciprocating engine, what is the primary disturbing force along the line of stroke? We all know each and every terms that is given in the question. Partial balancing means we do partial balancing of the reciprocating masses. You all know that. And what is the line of stroke? That is it. Okay, this is our line of stroke basically. So line of stroke, along the line of stroke, there is a component of the centrifugal force. We have seen that there is a mass m which is going to be attached here and which is having the radius of rotation of r, and this is nothing but the crank. Okay, like that you can see this is our crank. Okay, so and this is the connecting rod, and we know this is the line of stroke. Okay, because there is a piston which is going to be attached here. So if this angle is theta, so along the line of stroke there will be a primary unbalanced force that would come out to be mr omega square cos of theta. This is clear. Okay, this is clear to everyone. But when we have studied the primary balancing, we have seen that there is a mass b which is going to be attached here, and which is the radius of rotation of small b. So another component will be there in that directions along the line of stroke. So this would be considered as bb omega square. But we know that we do partial balancing of the reciprocating masses. So in case of partial balancing, bb is equal to cmr. C is nothing but the fraction of the reciprocating mass to be balanced. Okay, that means C value of C is always in between 0 to 1. Okay, so bb is equal to cmr. So you can write it as cmr omega square cos of theta. Okay, and this is another component. So you can see there is what is the primary disturbing force. So if I ask you to find out the primary disturbing force or primary unbalanced force, so it would be comes out to be 1 minus c mr omega square cos of theta. This is the primary unbalanced force along the line of stroke. In the question, it is asking that the primary unbalanced force along the line of stroke. So option C would be the correct answer. Okay. However, the options are basically different, so you can easily find out that option C would be the correct answer, because if I ask you to find out the unbalanced primary force perpendicular to the line of stroke, so it would be CMR omega square sin theta, but this is the perpendicular to the line of stroke. Okay, so in the question it is asking primary disturbing force along the line of stroke. That is the answer C. Option C would be the correct answer. Okay, however C is given in the question, and omega is the angular velocity of the crankshaft and theta is the crank angle. Okay, and one more thing that we need to understand, that if we talk about the reciprocating masses, so it is partially balanced. But if I'm talking about the rotating masses, it is completely balanced. Because in case of reciprocating masses, when we design the engine and when we try to balance the reciprocating masses completely, we have seen that the engine failed in balancing of the reciprocating masses completely to run the engine for longer periods. So that's why we need not to balance of reciprocating masses completely, we will balance it partially. Okay, so that's why partially balancing is there. Basically it is a part of the primary balancing. Okay, this is not a part of the secondary balancing. We do partial balancing in primary balancing of the reciprocating masses. Okay, so that's the answer for this question. Okay, so thank you.